Okay, now we are on to mole ratios in chemical formulas. So write the correct ratio on the line. What is the mole ratio of hydrogen to oxygen? So I just use the subscripts. What is the subscript for hydrogen? 2. The subscript for oxygen? 1. Because there are no parentheses, so it's real simple. So the mole ratio of hydrogen to oxygen in that formula is 2 to 1. What is the ratio of hydrogen to oxygen in this formula? 2 hydrogens to 2 oxygens. But, remember when we just did all that practice with balancing? I can divide both of these by 2. So the correct ratio is 1 to 1. This is an incorrect ratio because I can reduce it. Okay. What is the mole ratio of hydrogen to oxygen again? In this formula, it is 4 hydrogens to 3 oxygens. And nope, I can't reduce that. What is the biggest tip when doing this? Just make sure you put them in the right order, because if it asked for the ratio of oxygen to hydrogen, you would write it this way. Okay? So just be careful for that. Mole ratios and formulas, easy peasy. Okay, now we're going to look at mole ratios in equations, and we kind of already did it when we looked at balanced equations. This has no coefficient in front of it, so it is 1. This has a coefficient, it is 8. This has a coefficient, it is 5. And this has a coefficient, it is 6. So that's if we're looking at the ratio for the whole equation, okay? But we're not looking at the whole equation, we're just going to look at pieces of it. So oxygen to water, okay? So what was oxygen's? 8. What is water's? 6, right? But I have to think about, can I divide both of these numbers by something? Yes, I can divide them both by 2. So I get 4 to 3. Now can I divide them both by something? No. So the correct ratio is 4 to 3. Let's look at this one, of the hydrocarbon. Well, what the heck is that? What's the hydrocarbon? Well, it means it has hydrogen and carbon. So it is 1 to water, which is 6. Well, since it has a 1 in the ratio, I definitely can't reduce it, so I know I'm done. The ratio of carbon dioxide, 5 to oxygen, 8. Well, I cannot divide 5 and 8 by anything other than 1. Water to oxygen. I can divide them both by 2, 3 to 4. Now I can't divide them by anything else. So there you go. That's how you use the coefficients in the balanced equation. Remember, they had to be the smallest whole number coefficients to write ratios. Okay, remember how we just looked at mole ratios? Okay, so we're going to use mole ratios to now do some more math. So if I look at the whole equation, my ratios are 3 to 2 to 3 to 2. Okay, so this says I have 8 moles of magnesium chloride. So that's right, this. So I have 8 moles of magnesium chloride react with enough aluminum. So I know it's enough, right? So that means this all gets used up. So I want to know how many moles of aluminum chloride are produced. Well, if I have 8 moles of magnesium chloride, right? I want to know how many moles of aluminum chloride of this aluminum chloride. Well, so what the heck do I do? Well, I like to do it this way. Is just set up a ratio. So these the ratio from this balanced equation tells me all about magnesium chloride and aluminum chloride. It says that if I have 3 moles of magnesium chloride, I will get 2 moles of aluminum chloride. I don't have that amount. I have 8 moles of magnesium chloride. But now that I have this set up, right, I can just cross multiply to solve for this correct answer. All right. So I will get, if I just use the math, I will get 8 times 2 equals whatever times 3. What's 8 times 2? 16 something times 3. Divide both sides by 3. So let's do 16 divided by 3. 5.3333. So 5.3. So let's see though if it makes sense. If I have 3 moles, I get 2 moles. So it's less, right? If I have 8 moles, I get 5.3. Does that make sense? It does. It's at least logical, right? Okay, so let's find the next one. It says, how many moles of magnesium chloride are needed to react with 10 moles of aluminum? So I only mentioned 2 things, magnesium chloride and aluminum, right? So I'm going to have moles of magnesium chloride and moles of aluminum. And I'm going to set a ratio, right? Moles of magnesium chloride, moles of aluminum. I'm going to get 1 from the equation. So use the coefficients, 3 in front of magnesium chloride, 2 in front of aluminum. And now I'm going to go to the question. It says, how many moles of magnesium chloride, so that's what I'm trying to find, with 10 moles of aluminum. All right, so cross multiply. 3 times 10 equals 2 times something. This is 30, right? Equals 2 times something. Divide by 2, divide by 2. 30 divided by 2 is 15. So 15 moles is what I get. Let's just make sure it makes sense, okay? If I have 3 moles, I get 2 moles. So the number on top is bigger. So if I have 10 on the bottom, I should have a bigger number, right? It's 15. It's logical, okay? All right, so let's see. We have 2 more. How many moles of magnesium will be produced if 7.5 moles of aluminum react completely? So what do I have mentioned? Moles of magnesium and moles of aluminum. So I'm going to have on both sides moles of magnesium, moles of aluminum. Now I need to go to the equation for a moment. So the coefficient in front of magnesium is 3. Let's go back. The coefficient in front of aluminum is 2. Okay. What do I have in the problem? 7.5 for aluminum. I want to find this. What do I do? Cross multiply. 3 times 7.5 equals 2 times something. 3 times 7.5. So I'm just going to do it here just to make sure you can see what I'm doing. Times 7.5 equals 22.5 equals 2. So divide by 2, right? Divided by 2 equals 11.25. So let's see if it makes sense. I have, because I'm trying to find the top number, I have 2 on the bottom and then I have 3 on the top. So 3 is bigger, but it's not double, right? It's not quite double. So on the bottom here, I have 7.5. So I should have a bigger number on top, but it shouldn't be double. Okay, perfect. Looks good. All right, last one. If 3.4 moles of aluminum react with excess magnesium chloride, how many moles of magnesium will be produced? So I just have to be careful here. When it says excess magnesium chloride, that means kind of like ignore it because it's just there's extra of it. I don't have to worry about it. So the two things that I'm going to compare are the one that has the number and then the one that says how many. So I have moles of aluminum and moles of magnesium, right? So it's going to have a ratio that's still moles of aluminum to moles of magnesium. So in the equation, well, I already looked those up. I just have to be careful to put them in the right spot. It was 3 for magnesium and 2 for aluminum. So this says 3.4 for aluminum. How many magnesium? So 3 times 3.4 equals, that hardly looks like a 4. Oops. So let's go back and fix it. I erased this line by mistake. All right, 3.4 equals 2 times question mark. So let's do 3 times 3.4. 10.2 equals 2 times something. Divide both sides by 2. So 10.2 divided by 2 is 5.1. So looks like it's the answer, but let's make sure it makes sense. So this has 2 on the top and then 3 on the bottom. So it's bigger, but not quite double. So this has 3.4 on the top. The number on the bottom should be bigger, but not quite double. It is. Beautiful. Makes sense. So that's how to do some mole conversions using ratios.